Okay, so today we're going to start chapter 5, section 2, and we're going to talk about trigonometric functions. Now, you might have remembered this from last year where we did SOHCAHTOA. This will be a little bit similar, but instead of memorizing like sine as being opposite over hypotenuse, we're going to be doing this again on a coordinate plane with ordered pairs. So over here it says the trig functions of an angle. Now your geometry teacher might have referenced the symbol there, theta. This is what we're going to be using for our angle measures. It sort of looks like this. Oh, this is theta. So this is going to be any angle that's going to be in standard position, and we're going to let the ordered pair P be any point that's going to be on the terminal side of our angle. Now, when we memorize these trig ratios here, notice we've got 3 additional ones that we probably didn't talk about in geometry. We've got the reciprocal to sine, which is cosecant, and we've got the reciprocal to cosine, which is secant, and then the reciprocal to tangent, which is cotangent. Now, what we're going to do is you're going to be given an ordered pair, and remember, in an ordered pair, it's xy. And then what we're going to need to do is calculate the r value, which is going to be our hypotenuse. And we're going to sort of use what looks like the Pythagorean theorem. So this r value here can be found by taking x squared plus y squared and square root it. Because remember, the Pythagorean theorem was x squared plus y squared equals r squared, or a squared plus b squared equals c squared. But remember, in order to find just what r equals, remember we would square root both sides, and that's how they develop this equation that we're going to use to find the value of r. Now, our value of r is always going to be a positive number. So, for example, in my triangle here, let's say I put my little angle here, theta, down here. Remember, last year in geometry, we would label our sides as hypotenuse, opposite to the angle, and adjacent to the angle. And then if I were doing sine, I would be doing so, which is sine is opposite over hypotenuse. But now what we're going to be doing is the opposite side is going to be the y value of our ordered pair, and the adjacent is going to be x, and the hypotenuse is going to be the r value. So you're going to need to find some way to memorize these 6 trig functions. Whether or not you want to memorize it as sine, and think of the alphabet. So in my ordered pair, I always would remember that if I say the ABCs, I know that X comes before Y when I say the ABCs. So maybe you can think about, for sine and cosine, that the C is the first letter. So it's going to get the first letter of the ordered pair. Like when you say the alphabet, A, B, C, D, E, F, G, C comes before S. So that's how you'll know the cosine gets the X, and then the sine gets the Y. One year, one of my students said they didn't think of the word sine as sine. They thought of it as the word sin. And then they thought about, like with religion, and they think, oh, why should you sin? Because it's wrong. And they always would associate the y of the ordered pair with the sine. So whatever tricks are going to help you, just memorize that sine is going to be y over r, cosine is x over r, and then tangent is going to be y over x. Now, x, and on these ratios for tangent and cotangent, that denominator can't equal 0. Otherwise, it's undefined. Then the reciprocals, and I know I wrote on top of this, the reciprocal function to sine is cosecant, so you just flip the fraction. It's then r over y. the reciprocal to cosine is secant, so r over x, and then tangent, its reciprocal is cotangent, flip the x and the y. So find a way to memorize these 6 trig functions, because we're going to be giving you an ordered pair, and you're just going to plug in the ordered pair in for x, y, and r. You'll have to calculate the r using that equation, r equals x squared plus y squared. And again, the r value will always be positive. The x and y can be negative because it's an ordered pair. It all depends on what quadrant the ordered pair is located. So for example, down here, when your angle measure is here in quadrant number 1, so this is quadrant 1, I know that the signs on my ordered pair in quadrant 1, so over here, like if I do my coordinate plane here, remember this is 1, 2, 3, and 4. Remember the signs in quadrant 1, this is going to be a positive ordered pair. Over here, my ordered pair will have a sign of a negative and a positive. In quadrant 3, the signs are negative, negative. And in quadrant 4, it'll be positive, negative. Keep putting a 1 there. Okay, so over here, what we're going to do is I'm going to teach you a cool little acronym to help you remember which trig functions are going to be positive in each of the different quadrants. So because both of my signs are positive in quadrant 1, all 6 trig functions, when I do and plug in the x and the y, all 6 are going to be a positive fraction. So all 6 functions, sine, cosine, tangent, cosecant, secant, and cotangent, all 6 functions are positive in quadrant 1. In quadrant 2, which is this next one, if your angle is in quadrant 2, then we know that the signs here are negative, positive. So in this case, the only functions that are going to be positive in this one are going to be sine and cosecant. It's reciprocal. These are the only positive ones. The other 4, cosine, secant, tangent, and cotangent, these are all going to be negative fractions because of the ordered pair sign in quadrant 2. Because remember, the ordered pair here, this x in this quadrant is going to be negative. So if the ratio or the function has an x in it, that's how you can tell it's going to be negative. And that's why these 4 are all negative, because they all have an x in it. Remember, sine and its reciprocal, this is y over r. That's why this one's positive, because my y value here is positive in quadrant 2. Then in quadrant 3, remember in quadrant 3, the signs are negative, negative. So the only ones that are going to be positive here are going to be tangent and its reciprocal, cotangent. The other 4, the sine and its reciprocal, the cosine and its reciprocal, these are all going to be negative. Because if you think about it, the x and the y here in quadrant 3, it's a negative x, negative y. And remember, tangent, you're memorizing it as y over x. But if you put a negative over a negative, it's going to simplify to a positive. So that's why tangent and cotangent are positive in quadrant 3. Then in quadrant 4, the signs are going to be positive, negative. And the only functions that are going to be positive here are going to be cosine and its reciprocal. All the other ones, sine, cosecant, tangent, and cotangent, these are going to be the negative ones. Again, you can look at the signs because my x here is positive and my y is going to be negative, all of the ones with a y are going to end up being negative. Now I've got an acronym that'll help you to remember which ones are positive in each one of the quadrants. So my acronym is this. It's going to be all students take calculus. So each one of the letters, all, or this one is all. So all 6 are positive. The S in the word students, this is going to be for sign, and it's reciprocal. These are the only positive ones. And then for the T, that's for the tangent, and it's reciprocal. These are the only 2 positive ones. The other 4 are negative. And then the last quadrant, the C in calculus, this is going to stand for cosine, and it's reciprocal, secant. These are the 2 that are positive in quadrant number 4. So this is 1, 2, 3, and 4. Now we're going to use the location of the angle to help us narrow down some of our solutions. Now, when they give you an ordered pair, and for example, when you graph it, so for example, if I were to graph the ordered pair, say 3, 4, let's just say it's the ordered pair 3, 4. So this is the angle that's, the point is on that terminal side. So this is the angle theta that we're referring to. And then when we go to make the triangle, we always go back to form the triangle to the x-axis. And then this would form the right angle here. This is going to be the x value because it's along the x-axis. This is the y. And then we would have to calculate the r using our r equals x squared plus y squared. So let's try some examples. Using these 6 trig functions that you're going to memorize, and then from there you'll know by using your acronym, all students take calculus, which way to check to see if your answer is correct. So let's try the first one. So it's telling us that the terminal side of angle theta in standard position passes through the point 815. Notice both numbers on my order pair are positive, positive. So this tells me when I graph this order pair, it's located in quadrant 1. So, okay, so for here, let's go ahead and graph this order pair. So I'm going to go ahead and make my little axis here. I don't need to show the large part. I just need to make quadrant 1 kind of big. So if I graph the order pair 8, 15, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, it's way up here. Okay, so here is my point 8, 15. The length of R is from the origin 0, 0 to that point. The other side of my triangle comes back to the x-axis. And then this leg is formed by the x-axis here. So this is my R value. This is my x. This will be my y. So I can see from my order pair, x equals 8, y equals 15. Again, if you want to memorize it as opposite and adjacent, that's up to you. But again, it's easier because you're going to be given ordered pairs to memorize the different ratios using the x and the y. So now what I need to do is find this value of r. And to do that, I'm using r equals x squared plus y squared, and then I square root the answer. Now, if we end up with any radical answers, you need to remember that if that r value is in the denominator, we need to rationalize. But this first one, it'll be a perfect square. If you remember your Pythagorean triples from geometry, this is actually a Pythagorean triple. It's the 8, 15, 17 triangle. But again, you don't need to memorize the triples, just plug it into the formula. So I'm going to be doing 8 squared plus 15 squared. I square them, I add them, and then I square root it. So this gives me 289, square root it, and my R value is 17. Here's where memorizing the 6 trig functions comes into play. So your first 4 questions in the homework tonight is this. You're going to be given an ordered pair. You're going to find the values of the 6 trig functions, and this is what I'm about to do. So once you find your value of R, now we're going to plug them in. So you're going to memorize that the sine of theta, and theta is located right here. So the sine of theta, you're memorizing it as y over r. So again, if you want to remember it as why should you sin, it's always the y over the r. My y value is 15. My r value is 17. That's my first answer. Now, if you want to go ahead and do its reciprocal right away, all you got to do is flip it. And the reciprocal to sine is cosecant. And you would put r over y, just flip the letters, and then this becomes 17 over 15. Now, don't get confused. Don't think that the 2 S words or abbreviation go together and then the 2 C's. It's got to be an S and a C together. So sine and cosecant, and then cosine and secant go together. So then now cosine, since the sine has the y, cosine gets the x over r, and you put 8 over 17. Its reciprocal is secant, r over x, 17 over 8. And then lastly, tangent. You're going to memorize tangent to be y over x. Take your y, 15 over 8. Its reciprocal is cotangent. Flip the y and the x, and then just put in the numbers, and you're done. So the first 4 questions in the homework, this is all you're doing, is just putting in the numbers, the x, y, and r, into the 6 trig functions. Again, the ordered pair that they're giving you is on the terminal side of that angle. Remember, yesterday we saw this is the initial side, and then this is the terminal side. So this is the angle that they're referring to. So let's try the next one. I'm going to graph it. Notice the signs on this. They're negative, negative. This should be a clue that you're ending up in quadrant 3. Now, also remember our little acronym here. All students take calculus. Remember, all 6, for this ordered pair that I just did, all fractions should have ended up being positive. If you ended up getting any negative fractions here for this answer, you did something wrong. The next one that I'm doing is going to be in quadrant 3. Again, all students take calculus. Since this ordered pair, negative 3, negative 4 is in quadrant 3. Remember, in quadrant 3, the T is tangent and cotangent. So once I put my numbers into the fractions, the only fractions that should end up with a negative answer are going to be the other 4. The sine, cosecant, cosine, secant. These are the only ones that are positive. Everybody with me on that? All right, so let me graph it. Then I'm going to find the R value. Then I'm going to plug it into the 6 things. So here is my graph. Let me make quadrant 3 a little bit bigger. So this time I'm graphing the ordered pair negative 3, negative 4, 1, 2, 3, 1, 2, 3, 4. So I'm going to come here. So again, this is going to be my hypotenuse or my R value. And again, we can just go right to the point. We don't have to draw it all the way. And then remember, you always go back to the x-axis to form your triangle. So this is my triangle now. I'm going down to the x-axis. My theta is located right here. And again, this is going to be my x. And it's going to be negative. And it was negative 3. let me just put it as a -3. That's what x equals. And then your y is the -4. I need to calculate the r value. This is also another triple. This is that classic 3, 4, 5 that is going to show up all over SATs. But again, we can do our r equals x squared plus y squared and under the square root. So my x was -3, my y was -4. Once I square them, they become positive. I'm going to add them and then square root it. And r equals +5. Again, remember your r value will always be positive. Now that I found x equals -3, y equals -4, and my r equals 5, now I just have to do is plug them in to the 6 functions. Again, once I'm done, the only ones that should be positive fractions are tangent and cotangent. The other 4 are negative. So if I plug it into sine of theta, remember you're memorizing as y should you sin, so y over r. And then you plug in the y is -4, the r is 5. I'm going to go ahead and do its reciprocal right away, and that's the cosecant. Flip it, it's now r over y, so 5 over -4. So again, I'm on the right track. I've got 2 negative functions here, and these are supposed to be negative. And now let's do cosine. X over r. My x is -3. The r I calculated is 5. Its reciprocal is secant. Flip it. 5 over -3. Here's where my positive fractions come in, because in quadrant 3, tangent and cotangent are positive. Remember, tangent is y over x. So -4 over -3. Negative divided by a negative. That's why this becomes positive. Same thing for cotangent. Do an x over y. -3 over -4. Negative divided by a negative is +3 over 4. So again, because we did our all students take calculus, and I know that in quadrant 3, T stands for tangent and cotangent. These are the only 2 that are positive in quadrant 3. So this is what you're doing in the first 4 questions of the homework. You're going to go ahead, find your r value, and then just plug in the x, y, and r into the 6 functions and make sure you memorize those. All of this is for when your angle is actually located in the quadrant. When it's on the axis, these are called quadrant angles. And that's what we're going to see on the next slide. So when you want to find the trig functions of the quadrant angles, and these are going to be angles that are on the axis, so like the 90-degree angle, the 180, the 270, the 360, what we're going to be using here is going to be the ordered pairs on each one of these axes. So again, when we're doing actual angles in the quadrants, remember this is quadrant 1, and then if we use our acronym all, and these are all positive. Quadrant 2, this is students, so this would be, this is the acronym. So sine and its reciprocal of cosecant. These are the positive ones. Then in quadrant number 3, this is take. So the T is for tangent and cotangent. These are the only positive ones. And then in quadrant 4, this is calculus. And the C stands for cosine and secant. And those are the only positive ones. Now, we're going to be referring to the quadrant angles. And when we do this, we're going to be using ordered pairs that are on the axis. So for example, for a 90-degree angle here, if I were to measure it, it would come up here, and I would be using this ordered pair of 0, 1. If I am making a 180-degree angle, then I'm going to be using this order pair, -1, 0. And then if I'm using the 270, going to come all the way around, and I would be using this order pair. And then for a full circle, the 360, I'd come all the way around, and I use the 1, 0. So this is going to be the X and the Y that I use. What's nice about this is my R value for all of these is going to be 1. So when you use these 4 order pairs that are on the X and the Y axis, you don't need to do the calculation for R. But I'm going to show you an example. Let's say I wanted to do the 90-degree angle here that I'm going to ask you to write the 6 trig functions for. So when I'm doing a 90-degree angle, I'm using the order pair 0, 1. This is my X and my Y. Remember to find the R value. You're doing X squared plus Y squared and leaving it under the square root. So 0 squared plus 1 squared, 0 plus 1. The square root of 1 is 1. So no matter which one of these 4 order pairs, when you plug it into this formula, the R is always 1. It makes it a lot easier just to use those order pairs. This is sort of leading us into the unit circle, which we're going to be talking about later on. Notice, think of the unit circle, or this R value, this is a radius, and the radius length here is just a 1. So let's go ahead, now that I have my X and my Y, because again, for 90 degrees, we're using this order pair. So again, 0, 1, X and Y, and then I just calculated the R, and it's 1. So X equals 0, Y equals 1, R equals 1. I'm going to go ahead and plug this in to each one of these. Again, you're going to memorize the rules. Remember, sine is going to be Y over R. My Y is 1. My R is 1. So the sine of 90 is 1. Then for cosecant, just flip it. So now it's R over Y, still 1 over 1, and it's 1. For cosine, X over R, 0 over 1. Remember, when there's a 0 in the numerator of a fraction, it simplifies to 0. However, now when I flip it, I get 1 over 0. This is no solution. It's undefined. So when the 0 ends up in the denominator, know it's undefined for the secant. Tangent, you're memorizing it as Y over X, 1 over 0. This one is also undefined. And then cotangent, flip it, X over Y, 0 over 1, this one equals 0. Now we'll do the 180. We're still using the same R value, but the order pair I'm using for 180 is over here. Because remember, on your quadrant angles, the 180 is located right here. So for this one, my X value I'm using is -1, because I'm using the order pair -1, 0. My Y is 0, and R is 1. So let's plug it in. So Y over R, 0 over 1 equals 0. Flip it, R over Y, 1 over 0, no solution, it's undefined. Cosine, X over R, -1 over 1, -1. Flip it, R over X, 1 over -1, also simplifies to -1. And then tangent, Y over X, simplifies to 0 over -1. 0 is in the top, so it simplifies to 0. But when I flip it, now it's undefined. So -1 over 0, no solution. So when they ask you to find a 90-degree angle, a 180, a 270, or 360, you're using these axis points. Now, same thing if you went clockwise. So you would still use the same ordered pairs as if you were doing a negative angle as well. So the 90, you could do it clockwise and still use those ordered pairs on the X and the Y axis. So the next slide has the reciprocal identities. Now we've already seen that the reciprocal to sine is cosecant. So sine of theta is really equal to 1 over cosecant theta. Cosine, its reciprocal is secant, so it's equal to 1 over secant. Tangent, its reciprocal is 1 over cotangent. And then the same thing down there at the bottom. So we're going to be using these reciprocal identities later on when we're going to be verifying and doing different things with the functions. So for example, to use these reciprocal identities, let's say I told you that the sine of theta was equal to 4 over 5. And I ask you to find cosecant. Well, we already know that sine and cosecant are reciprocals, so all I have to do is flip my fraction. Because again, remember, you're memorizing sine of theta to be y over r, and cosecant of theta is r over y. So when they ask you, given this, find this, all you need to do is flip the fraction. Let's try some other ones. And you're doing this in the homework. So here it says, find cosine of theta if secant of theta equals 5 over 3. Well, I know that cosine and secant are reciprocals. So to write the cosine of theta, all I do is flip the fraction. This is using reciprocal identities. When you're doing the homework tonight, these are going to be questions 45 through 49. Next one, it wants us to find the sine of theta given cosecant. Again, these are reciprocals. So to do sine, I'm going to flip it, but here's where I need to rationalize. Because remember, we can't leave that radical in the bottom. So we're going to rationalize by multiplying the top and the bottom by square root 6. And I get -2 square root 6 over 6. Always simplify whatever's outside. So I can simplify this -2 and this 6. And this becomes the square root of 6 over 3. So the sine of theta rationalized is negative square root 6 over 3. Never leave that radical in the denominator. All right, so this is going to help us to identify if something's possible or not. These are some Pythagorean identities and quotient identities that you need to memorize. Now, in the homework tonight, you're going to get some questions. And they're going to, for example, give you something like this. They're going to say, given the sine of theta equals 2. They're going to say, is this possible or impossible? And the way that you can tell that is by looking at these solution intervals. Remember, what you're going to memorize is that the sine and cosine always needs to be either it's got to be a fraction, either a negative fraction or a positive fraction. Something in between -1 and 1. It can equal -1 and 1. Because remember, when we did the trig last year, and we did, for example, the sine of theta and let me come over here where maybe it'll show up better. So remember, when we did the triangles last year with trigonometry, if I wanted to do sine, let's just say it was like a triangle ABC here, and let's say I wanted to find the sine of angle B. Remember, sine uses opposite over hypotenuse, if you remembered the Katoa stuff. So opposite over hypotenuse. And then if you think about it, the hypotenuse is always the biggest side. So this answer was always a fraction because the hypotenuse is always the biggest side. And then the opposite side would have always been smaller. Same thing for cosine. Cosine would have used, let's say I wanted cosine of B, it used adjacent over hypotenuse. And again, the hypotenuse is always the bigger side. So that's why this interval for our answers, it's always got to be a fraction, a positive or a negative fraction. So if they ever give you a question like this and they say, could the answer of sine of theta be positive 2? You would say that this is impossible because it has to be a positive or a negative fraction. However, remember, secant and cosecant, these are reciprocals of both of those. So those answers have to be greater than positive 1 or less than negative 1. The answers to secant and cosecant can't be fractions. So for example, if I said, could secant of theta equal 2, you would say that this is possible. So when you get to the questions in the homework where they want you to classify, is the answer possible or impossible, you're looking at these solution intervals. Now tangent, because it's y over x, and it doesn't matter if the opposite or the adjacent was bigger or smaller, tangent and cotangent, this could be anything. So it's all real numbers. So negative infinity to positive infinity. So if I told you, could the tangent of theta equal 100? Absolutely, because it could be any number. So this is possible. It could have also been, could tangent of theta equal 1/2? And you would say, absolutely, it's possible, because tangent could be any number. So when you get to the homework for the possible or the impossible questions, you're looking and memorizing the solution intervals. Now, for the Pythagorean identities here, you need to be able to manipulate these and memorize these 3 Pythagorean identities. And what I mean by manipulate them, we're going to be using these Pythagorean identities for like substitution. You're going to need to memorize them, both of these. So when you have a Pythagorean identity, be able to take, for example, the first one, and be able to solve it for sine. So for example, I could subtract cosine theta from both sides and solve it for sine squared theta. And it would be 1 minus cosine squared theta. I could have also rearranged it and solved it for cosine. So sine squared theta plus cosine squared theta, this is a new problem. Let's say instead I wanted to get cosine by itself. So I could move the sine squared theta to the other side. And then I could get cosine squared theta all by itself. So be able to manipulate any of these 3 into different forms. Because again, we're going to be using these later on to simplify things. Another thing is you always need to include the theta. So once we get into the verifying and the simplifying, don't just tell me that this first Pythagorean identity here is just sine squared plus cosine squared equals 1. If you show me this on a test, I'm going to mark it wrong because you need to include the theta here. It always needs to have an angle measure there. So just don't forget that. Don't leave off that angle measure.